Welcome. Today, we're setting the record straight about one of the Pacific Northwest's most awe-inspiring natural wonders. We're diving beneath Mount Rainier, a towering giant that dominates the skyline and captures the imagination of millions. This volcano isn't just a beautiful backdrop, it's a source of fascination, concern, and sometimes wild speculation. Recently, the internet has been buzzing with rumors, claims of secret magma tunnels, mysterious satellite warnings, and even a supposed USGS red alert. These stories spread quickly, fueled by dramatic headlines and viral posts. It all sounds like the plot of a blockbuster disaster movie. But let's pause for a moment. We're here to separate fact from fiction, and to understand what's really happening beneath our feet. The latest story making the rounds? That Mount Rainier, Mount St. Helens, and Mount Hood are all secretly connected by vast underground magma highways, supposedly threatening an epic catastrophe. It's a dramatic idea, but the reality is far more nuanced, and, in many ways, even more fascinating. The science tells a story that's complex, layered, and worth exploring. Our mission today is to cut through the noise, look past the hype, and see what the experts and the data actually reveal about these volcanoes. We'll examine real seismic data, review expert reports, and uncover what's truly happening deep beneath these iconic peaks. Yes, there's been recent seismic activity at Mount Rainier, but it's not the apocalyptic scenario some headlines suggest. Instead, it's a window into the dynamic processes shaping our planet. What we find is a complex, fascinating system of shifting rock, heat, and pressure, far removed from doomsday hype, but no less incredible. So let's leave panic behind and embark on a journey to discover the real forces shaping our world, and the science that helps keep us safe. We'll learn what an earthquake swarm really means, how scientists monitor these events, and how to separate fact from viral fiction. Let's get started. To understand the rumors and concerns that often swirl around volcanoes, we first need to understand what earthquake swarms really are, and why they matter. Unlike a single, powerful earthquake that strikes suddenly, an earthquake swarm is a rapid series of many small tremors, all happening in the same area over a period of days, weeks, or even longer. These swarms can sometimes include dozens or even hundreds of tiny quakes, each too small to cause damage on their own, but together they can attract a lot of attention. For volcanologists, these swarms are important signals. They can indicate that something is changing deep underground. Sometimes it's magma moving, sometimes it's just shifts in the Earth's crust, and sometimes it's not related to volcanic activity at all. Magma pushing its way through solid rock can cause these tiny earthquakes, but so can water or gas moving through cracks and fissures beneath the surface. The Earth is full of surprises, and not every tremor means an eruption is coming. Distinguishing between these different causes is a key challenge for scientists. They have to carefully analyze patterns, depths, and locations of the quakes to figure out what's really happening below. Think of an earthquake swarm like a fever in the human body. It's a sign that something is going on, but it doesn't always mean something dangerous is about to happen. It's a symptom, not a diagnosis. That's why scientists look for other clues as well, like ground swelling, changes in gas emissions, or heat escaping from the ground, to help them diagnose the true cause of the swarm. A swarm by itself is more like a question than an answer. It tells us to pay attention, but it doesn't tell us exactly what's happening or what will happen next. In fact, most earthquake swarms are harmless, and simply part of a volcano's normal, restless behavior. They come and go without any eruption or danger. Careful, continuous monitoring helps scientists tell the difference between routine activity and real warning signs that might require action or alerting the public. So, when you hear about an earthquake swarm, remember, it's a signal to watch and learn, not a sentence or a guarantee of disaster. Now, let's see how all of this applies to Mount Rainier and what scientists are watching for there. Meet the stars of our story: Mount Rainier, Mount St. Helens, and Mount Hood. These Cascade volcanoes are part of the Pacific Ring of Fire, shaped by tectonic forces. Rainier towers over Seattle, covered in glaciers, and is closely watched due to its potential hazards. St. Helens erupted dramatically in 1980, reminding us these mountains are very much alive. Mount Hood, Oregon's tallest peak, is a familiar sight for Portland, and has erupted in the past. Each volcano has its own unique history and underground plumbing. They're not connected by tunnels, but by the same deep tectonic processes. Their eruptions and behaviors are independent, shaped by local geology. Understanding their differences is key to separating fact from fiction. These giants are fascinating, but not linked by secret magma highways. Now let's look at what really happened at Rainier in 2025. In July 2025, Mount Rainier's monitoring network detected a surge in tiny earthquakes, the largest swarm ever recorded there. Over 7 weeks, about 1,350 small quakes occurred, the biggest only magnitude 2.4, too small to feel. The swarm peaked early, then faded, with quakes clustered 1.5 to 4 miles beneath the summit. Scientists were intrigued, but the data showed no signs of danger. No ground shaking, no surface changes. Just a lot of faint tremors. The USGS reported. Lots of tiny, unfelt quakes all beneath the summit, peaking and then declining. No other unusual activity was detected. The event gave scientists valuable data, but nothing suggested an eruption was imminent. The facts were clear, a record swarm, but not a crisis. So, what about those rumors? Let's bust the biggest myths about the Pacific Northwest's most famous volcanoes because there's a lot of misinformation out there. First up, no, satellites did not detect giant magma tunnels linking Rainier, St. Helens and Hood. Despite what you may have seen online, there's no secret underground superhighway of molten rock connecting these volcanoes. There's zero scientific evidence for this idea. In fact, geologists have studied these mountains for decades, using everything from seismic waves to satellite imagery, and have found nothing to support the tunnel theory. The USGS and NASA constantly monitor these volcanoes. If tunnels existed, their instruments would have picked up unmistakable signals, changes in ground movement, heat, or gas emissions. Instead, each volcano has its own separate magma system. Think of them as neighbors living in their own houses, not roommates sharing a single pipeline. Second myth, no red alert was ever issued for these volcanoes. There was never a moment when officials warned of an imminent eruption. The USGS alert level stayed at normal, green, the entire time, meaning there was no increased threat or unusual activity. A red alert is only issued when an eruption is actually happening or about to happen. That scenario simply never occurred. So what caused the recent earthquake swarm that got everyone talking? The answer isn't magma on the move, but water, hydrothermal fluids circulating through cracks above the magma chamber, deep inside the mountain. This is actually pretty common in active volcanoes. Hot water and steam build up pressure, causing tiny earthquakes as they force their way through rock. It's a sign of a hot, dynamic interior, but not a sign that an eruption is about to happen. These are natural processes, not warnings of disaster. The rumors of tunnels and imminent catastrophe, they're pure fiction, fueled by viral posts and sensational headlines. The real story here is about the fascinating interaction of water, heat, and rock, not about impending catastrophe. Science, not speculation, tells us what's really happening beneath these iconic peaks. Trust the data, not the drama. So let's put the rumors to rest and appreciate the real wonders of these volcanoes, without the hype. How unusual was the 2025 swarm? Bigger than usual, but not unprecedented. Mount Rainier has 1 or 2 small swarms every year, part of its normal behavior. The 2025 event was the largest on record, lasting weeks and producing more quakes than ever before. But it's still part of a known pattern, not a sign of something new or dangerous. During the swarm's peak, quakes were much more frequent than normal, which caught scientists' attention. Careful analysis showed the cause was fluid movement, not magma intrusion. Rainier hasn't erupted in about 1,000 years, and there's no evidence it's due. Volcanoes don't work on a schedule, they operate on geological time. The 2025 swarm didn't change the long-term outlook. It was a fascinating event for scientists, not a warning of disaster. Understanding context helps us see the difference between normal activity and real risk. Let's see how scientists keep watch. Modern volcano monitoring is a scientific marvel. Networks of seismometers, GPS stations, and satellites keep constant watch on volcanoes like Rainier. Seismometers detect tiny tremors, GPS and satellites track ground swelling. Gas sensors sniff for volcanic emissions. During the 2025 swarm, no ground deformation or unusual gas emissions were detected. Key evidence that magma wasn't moving. Scientists combine all these data streams to get a complete picture. They don't rely on a single clue, but a holistic view. This approach let the USGS confidently keep Rainier's alert level at normal. The real work is quiet, careful, and ongoing, far from the headlines. Thanks to this vigilance, communities stay safe and informed. Science, not speculation, is our best defense. In today's world, rumors spread fast, often faster than facts. The magma tunnel story is a perfect example. Dramatic but false. The real challenge is learning how to find reliable information. Ask, who's the source? What's the evidence? Is it from the USGS or just internet hearsay? The USGS provides real-time public data. Go straight to the source. By seeking out primary information, you become an informed participant, not just a rumor consumer. The real story of Rainier's swarm, heated water moving through ancient rock, is just as fascinating as any fiction. Embracing real science deepens our understanding and appreciation of the planet. Stay curious, ask questions, and always look for evidence. The truth is out there, if you know where to look.